Control P to instance our agents. If we hit the spacebar, we get nothing because they don't have brains. Let's bring on an output node, set it to TZ, set the range to 0 to 5, set the value to say 5, and now hit the spacebar again, and of course they're moving, but they go straight through each other. So we want to use agent fields to stop them going through each other. Spacebar, Alt R to reset. Let's go edit agent fields, and we can add an agent field. It will be a repel field, and it will be called repel by default. There are 3 types of fields: repel, attract, and align. And in this case we want a repel field. Now by default it has only distance switched on. There are several other ways that we can select agents for affecting this field. In this case we'll just try distance for now, and we can see the distance value here, which is currently about 1 to 2. Now we need some defuzz nodes, so we'll start with, say, Go, connect that to our output node, and set a value of, well, it should be 5. It didn't get the range. Here we go, 5. Now we get another defuzz node, and we'll call this one Stop, and connect that one. Of course that one will be 0. In this case we want Go to be else, because we're going to be using the agent field to stop the agent. Now we get an input node, and select agent field, repel, and Z. So the agent field is kind of like a particle force, and in this case if the force is pushing backwards, then that means that there's something in front that is repelling the agent. Now we'll get a fuzz node, and we'll call it back, because our agent field force, if you like, will be pushing the agent back. -1 to 1 is a good range for an agent field input, and in this case we'll set the fuzz node to something like this, basically -1 to 0, and we'll connect that to stop. Now let's see what happens. Okay, our agents stop, but not very well. So they kind of stop a little bit late is the worst thing. And so if we go to distance here, we can actually view the agent field for the currently selected agent, and we can see that the agent field is very small, so it's only going to respond to agents that are very near. We can make that a bit bigger by dragging out this value here, and we will see that change in the viewport. So maybe about 1.3 to about 5.2, and now let's try that. Okay, that's better. There's still a few confused agents, and that's because they're responding to agents completely all around them, whereas we really only want them being repelled by agents that are in front of them. So we switch on the X polar coord, click on that, and we can see the graph for that. And now we can set that to, say, about -60 to 60 would be good in this case. You can just play around with these values till you get the kind of behavior that you like. And the outside values about 115 maybe. Oops. Right, and let's see what that does. Okay, that's much better. So now our agents are successfully avoiding collisions, but they do tend to basically clog up because they're only using the agent field to stop. They're not using it to turn to avoid collisions. We can add that. So let's bring on another output node, this time RY. Set the range to -90 to 90. And let's get some defuzz nodes. Left, center. or rather straight, which would be our else, and right. Oops, that's it. Now the value for left should actually be positive, and the value for right should be negative. It's just the way that the coordinate system works. Alright, now we need another input. Again, we want agent field repel, but this time X for sideways repelling. And we want a left and a right. Again, the range should be -1 to 1. And we want left to look like this. Go from about 0 to about 0.3. Again, a positive value, it means left. And we can up or down arrow to get to the other fuzz node. Set that one to about -0.3 to 0. Now we can connect left to left, right to right, and let's see what happens. Great, now we've got some rather nice behavior with the agents avoiding collisions. Now we can improve this. The agents tend to slow down a lot because they're being very cautious about collisions, and that's because if we have a look at the agent field here, you'll notice that it's very wide, which is great for turning to avoid, but not so good for slowing down, because we don't really need them to slow down for an agent that's beside them. So what we can do is we can add another agent field, and this time we'll give it a different name. We'll call it in front. And we'll switch on again the x-polar coord. Now for distance, let's set the distance a little closer, so about 1.2 something, and say about 2.9. That'll do. And for the x-polar coordinate, we want to be a lot narrower than the other field, so about -35, somewhere around there. Either way, to 35, and with the outside values of about 75, somewhere around there. Okay, now that won't make any difference yet because the brain doesn't look at the value of in front. But if we change this one from repel to in front, now it should have an effect. So now we've still got the agents avoiding each other, but they don't slow down so much because they're a little less cautious on the stop.